Perfect. So yeah, this is my part of the presentation on what's new in the upcoming versions of OpenBridge Designer and also OpenTunnel as well. So as Burak and Francois mentioned it yesterday, right? There is a new version that is coming, and the label of that is OpenBridge Modeler, OpenBridge Designer 2023. These are the platforms in which these new release is going to be based on. And what I'm going to mention here is the major updates that we have done or enhancements in the software. Now, of course, we're going to be placing all the enhancements. There are more than 25 different enhancements that we have done for OpenBridge Modelers, just OpenBridge Modeler. And the whole list is going to be, of course, on the release notes and also on our YouTube channel, in which we have listed all of them with, of course, its corresponding demo. So what are the major enhancements that are coming in OpenBridge Modeler 2023? First one is what we call the 2D and 3D separation, right? So, hey, don't get confused. This is not what we're trying to achieve is almost the same workflow as OpenRose is doing, starting in 2D and moving to 3D, right? But we started with this, in which the elements, the decorator elements, the outline, the shadow of the deck, bearing lines, beams, and footings were placed at elevation 0, right? In the 3D file, but at elevation 0. That creating, some issues on extra manipulation on the elements, because elevation 0 is 2D, right? So it should be on a 2D model. And then also when people were transferring this to the iTwins, it was seeing elements that really you don't want to see in a 3D model because, as I said, it's elevation 0. So what we did is to clean this up. So automatically now, there is an option that you can activate on the workspace, in which when you place the bridge itself, right? As you're placing the bridge, we will automatically place all these, let's call it elevation 0 elements in what they truly belong on a 2D model. So we will create automatically a model called decoration space, for lack of a better name, and all these elements will be there, right? But these elements will be connected to the bridge. So still you can pick from the 2D model options to edit parts of the 3D model, change properties, query properties, and all of that. So this is not a static element, it's dynamically connected to the bridge itself, right? That will ease as well on plans production, because now you can reference just the decoration space model rather than the entire 3D bridge. So this is something done automatically, but only if you activate the proper variable in the workspace. If not, it's business as usual. Everything goes into the 3D model. Right? Now, another enhancement here, concrete beam camber, right? As you know, when we model the bridge, we place the beams straight, right? The final condition. But people wanted to see how is the deflected section, and also to calculate, I would say more, I wouldn't say accurate, but precise, the deflections, even though we have the reports, but they wanted to see it graphically, right? So, and then also we get the added benefit of course, a more accurate 3D model and more accurate as well computer quantities. So we added for that option a new way or a new method to calculate the hunch. As you're using previous versions of OpenBridge, we have the start end. You specify the hunch. The Australians call it the hawk, right? But yeah, the hunch and the start end. The other option that we recommend to use as well was the start end and the computed one, the expected camber that we wanted to apply, right? And the last option, the new one that we included in this 2023 release, is the start, end, and middle. So you specify 3 different hunches definitions there, and the software will calculate it appropriately, of course, and then show that in the 3D model, right? So since each beam could have a different camber, well, you will have the real deflected structure there if you want to see it, right? So I can model that, very quick with the wizard, but then when I change on the beam definition, the way I want to calculate the hunch, right, I can activate any of these options and it will show me the new deflected structure. So just can copy this to all the beams now, since I didn't do it when I created with the wizard, right? And then you will see now that every beam will have sometimes a small deflection, right? Especially when the beam is very long, but a deflection nevertheless. So if I switch different views and clean this up, you will see now more clearly that the actual beam is really deflected, right? And then it will be used, of course, if you want to calculate vertical clearance and stuff like that. Yes, it will use that deflected section to display the options. Now, one more addition was the transition blocks, right? When we have beams of different heights or even different material, right? So we used to handle these with sometimes solid beam seats, right? So, but then what about the cap? The users wanted to actually modify the cap, and the only way to do it before was, yes, manual modification, with all the pros and cons of doing this manual modification, right? Because after you touch it and modify it, well, you lose the parametrics and you need to add every beam seed by hand. So now with this new enhancement, well, everything is parametric, everything is automatic. So we can handle, again, basically different heights. It doesn't need to be all concrete beams. It could be concrete and steel, as you can see in the picture. And it's all done in a dialog box. So when you define the cap, right, you can specify the height, the width of that transition block, as we call it, to achieve this, right? If not, again, it will be handled as it used to with a very different heights of a beam seat. If you, as you can see here, right? But then if you go right, different. That's how we used to handle it. If you still want to do it, of course, it's your choice. But then, if not, you can just edit the cap itself or edit the pier, and through a dialog box, just enter the numbers. So it could be part of the actual library, or you can do it. After you place it, of course. So it will be just a matter of activating the option of the transition block in the cap, right? And then specify where you want it, on the back station, the ahead station, and the dimensions of it, width, depth. So then after you do that, all the beam seats will be recalculated and placing accordingly. So very simple. I mean, to do. I mean, there is no much of a learning curve, as you can see. It's just specifying the dimensions that you want. This, of course, software is not going to calculate it, but you need to specify that. It will show you on the screen. And then when you just basically hit OK, everything will be recalculated. Again, this is the ahead or back station where you want to place a transition block. My case will be the ahead station. All right. So, yep, the ahead station. And then we just see OK, then it will be just recalculated and place it again. So this could be done, as I said, fairly quick there on that. Right? So now, what else we have done? Right? Now, some instances too, we wanted to place concrete diaphragms on the steel girders, especially on the abutments, kind of make it kind of an integral abutment, right? And the challenge was not only just to place the concrete block, right, but also the special blockouts or holes to accommodate for the beam seat, the actual steel beam. So, well, now we do it. There is no need to do it manually, right? And again, the big benefit is still your model remains parametric, and reporting, of course, is done on the elements itself. And the way to do it is just specifying the dimensions into the dialog box. There is no even a library item that you need to define. So it's just specifying the dimensions and also the size of the blockouts for the beam seats. So we can specify that. And as I said, it's when I finish placing this abutment, for example, right now I need to place a diaphragm that is not considered part of the abutment. It's actually a diaphragm, and I can do it at the beginning or at the end of the bridge. And as I said, it's just only specifying the dimensions, you know, you know, uh, width, height, distance from the last beam, if you want to do an extension or not. So, and it's pretty much self-explanatory. As you change the dimensions, you will see the immediate feedback on the screen on how this is done. Right? For example, my blockout was too small, so it's just a matter of changing the dimensions and see how to accommodate that. Now, the blockout is, of course, for every beam. It's not like you need to specify every dimension, but it's just that, for example, my extension here, my right extension was too much, so it's actually outside the deck, so I need to adjust for that. So that is concrete diaphragms on a steel beam. So it's just, again, another option of placed diaphragms. Now, the same as we Derek, I think, presented on yesterday about export to IFC. Yes, we have doing now export to IFC in OpenBridge. This is a very constant requirement right now, not only for the US projects, but also for international projects. So the challenge is what IFC format you want, what properties you want, right? And that's, again, this is something that it needs to be defined. The schema is changing constantly. You know, I think it's still under approval, the upcoming one, 4.3. So Building Smart has it, but then ISO still needs to fully approve it. So we're waiting for that. Nevertheless, we have the version ready, right? And then basically any bridge element or complex object can be exported to IFC. And then what about the properties that you can add and how you add these properties? Well, of course, you can add it element by element. So we do it through the option of item types. So this is a platform enhancement, right? So MicroStation does it, of course, Open Roads, but then also OpenBridge. Now, the technology to use is item types, of course, but then how to do it more automated rather than attaching IFC properties or general item type properties, element by element, that still you can do. Don't get me wrong on that. So what we have done is first the export to IFC and the properties of IFC. That classes could be embedded into the feature definition. That is how we did our automation. So when you do feature definitions, right, we have pier, abutments with piles, the standard ones I'm mentioning. Now you can add, as part of the feature definition, the IFC classification of the elements that you place. Right? So meaning that when you place a beam, the software already knows that, oh, this is the IFC classification that you have activated for that type of elements. So you don't need to attach it element to element. You just do it through the feature definition, right? So the way we do it, again, as the same as we do it with Open Roads, just the icon in the software, export to IFC, and it will connect to the cloud, and then grab the latest connectors, we call it, or civil connectors, to make the translation from our OBN model to IFC. The intermediate step that it creates an I model, a big model, but not on the cloud, in your computer. As you can see, it's on the C users folder. So you still have that big model inside that. But again, if you want to export IFC, it's just a matter of specifying what's the folder you want it, where you want it, right? So now, how you do this automatic definition? So, well, as you need to actually update on your DGN library for the feature definitions, right? We will include an example on our release on how this is done. But basically, is again, you need to open your feature library or the DGN lib where you have it, and the elements that you have, like for example, my feature definitions for abutments or piers, you need to add what I'm going to show you, right? So if I pick one, like deck, the easiest one, right? So I need to edit this feature definition, right? And as you can see on the properties, that's what I have. But look, items attached, none. Well, no, Now I need to attach, and that's the new addition, IFC. And on IFC properties, then I need to say, yes, I want the IFC classification for that. So when I place my deck, now I can specify in the standards what version of IFC I'm going to be exporting to, right? And we have, I think, the IFC versions to export from version 2 all the way to 4.3. That's supposed to be the latest. Then you need to specify what class it is. Software is not going to do it automatic. You need to specify that my deck, I'm going to include it as a bridge part, right? And then that bridge part is, or that bridge is what type it is. Oh, no, there's no bridge. I'm sorry. It's a bridge part, right? So again, you need to establish that classification for each of the elements. So it's a IFC bridge part, and then this is a deck, right? So now when I place my deck, well, of course, this will have this property fully automatic, right? So let's call it, this is the extra work that you need to do if you have different properties or you want to, select a different one. Same will happen with a girder, right? As you can see, it's type IFC bar type. Now there is more granularity coming, right? But these will come from the schema of IFC. So again, we're working with them on the AASHTO pool fund, in which they are specifying how they want to classify this. And this is our attempt to get at least the first properties of IFC for the elements that we model, right? So of course there's more to it, but this is, again, you will have this export this when all these properties will be part of the model itself when you export to IFC. So again, this is how you select the options. It's a search, so easy to look for it. And then maybe the barrier is not classified as barrier. Maybe they call it parapet to be more international. So you just need to specify. If not, for a lack of a better specification, you can just say superstructure, right? So it's, again, the classification is on you, how you want to do it. I mean, we include the whole schema, not just the bridge part, because as we learn, the building smart says they don't want to repeat elements. So if there is something in building that they can use, they will just use it as well. So again, this is part of your standards now, or you need to modify your standards. So it will be part of the feature. Then how you do it. Now, when the bridge is placed, right? Now, for example, you already have the bridge, but then we haven't applied these new standards. So you want to apply it. Well, you need to shake the bridge a little bit. What do I mean by that? Make a small modification so it will reread the DGN lib and it will apply the new properties and then change the modifications back. And then basically you shake the bridge a little bit and then it will get infused with all the new IFC properties in this case. So then after that, well, this is just a matter of saying, well, I need to export to IFC, right? So it will be on part of the utilities, same icon, right? And just to run it, very simple. What version you want? Remember, we place our properties with 4.3. Where you want it, right? Give it a name. And on the first time that you run this, it may take a little time because it's just bringing all the connectors from the cloud and putting that in your computer. So the second time it will run faster because you have already all the files local. And then you can use any viewer, like, I don't know, BIM Solibri, to get all the elements. And now you have your properties. So as much properties of IFC you get in, so then software will put all these definitions there. So now that, as I said, it's the export to IFC of bridge elements. So these are the major updates that are coming on 2023. Now, we also realize that you may have using older versions of OpenBridge because of DOT requirements, for example. There are DOTs that are still on 10.08. Some of them are moving to 10.10. Some of them are skipping a version and saying, no, we're going to the latest one, 10.12, or maybe this one, 2023. So, well, I have here for you is that the major updates that are happening from two previous versions. So this is the previous version of OpenBridge Modeler as well, right? And now, for example, on the previous version, well, now of course present on the latest one, that we have a constraint at one time that we can only place one beam, or excuse me, two beams. It has to be two beams, right? So if you do a top, it has to be dual tops, or you can only place two concrete beams. And if you have a widening with one beam, well, tough luck, we can't, right? So now, yes, now you can do a beam definition with a single beam. So again, nothing has changed, just the option that you can do a beam definition with one beam element. It could be steel, it could be your concrete, and it could be a box as well, right? So now also barriers on wing walls. You know, you saw Steve's presentation in which he was doing barriers as well. But then here, the deck, we used to stop the barrier at the end of the deck. Now we can specify, if you place a wing wall, elements on the wing wall in which a barrier could be newly placed or could be extended. So we're still recognizing that. Right? Now, the skew ends that, for example, Steve showed that it was manual. Yes, at one point it was manual, but now also we can do it automatically, in which we can cut not only the deck, because we got the deck breakbacks, I'm going to show that later, but also we can cut the barrier along the support line orientation too. So we can follow the skew, right? That would be the skew angle of the support line, or it could be normal to the path, so it will be radial to the alignment. So a single toggle in the dialog box or on the properties will just cut automatically the barrier that you have placed. And again, without losing the parametrics. That's the big thing here. So as I said, it's just a matter of specifying that. So as I said, very simple on that, in which you just specify how you want to cut when you place the barrier itself. So as you place it, it could be done immediately. It could be done after the fact, right? So as you can see here, normal to the path. The other one will be following the skew supports, and then you can change it at any time when you place it, or using the properties options after that. So that's, again, simple toggle. We just do it. We also have improved our bearing elevations, right? This is always a big request because, well, geometry, of course, is extremely important. So we wanted to report that, and also access all these bearing seats and bearing elevations through item types. Why? Because on that, you can do reports, right? You custom reports like bearing seat elevations tables that we need to sometimes place into our plans. So, and then you can just quickly query these, just hovering on the beam seat to get the top elevations there. And then use it, as I said, on item types, get access to that information, and maybe compose a table for that. Right? So that's a bearing seats elevations report. Now, we mentioned the 2D decoration space, right? So we keep adding information, right? You remember at the beginning, a few versions ago, I would say, we can only place the outline on the deck and the beam lines. So more and more, we are adding all these properties. And this new one is the 2D decorations for the bearing and the bearing seats. So if you need to do a plan view of your piers, well, that's it, right? This is the outline of the cap, the bearings and the bearing seats. So you can do it through a section, right? We can cut a section from the 3D model and show it on our 2D plans, or you can just reference that part, and then you already have a plan view of all your caps. So as you can see, you know, it's making a little bit easier to do plans production as well, having these 2D decorations be in place, and now even better, be in place in a separate model when you have all the 2D information of a bridge available without any extra clicks. Right? So just a decoration space. Of course, there is always limitations, like some people put the bearing seats with cells, right? So then we can only do the outline, not the actual sail itself, right? So that could be the complication, I would say, right? And it's, as I said, it's just a matter of specifying that, right? And using the levels that you specify, of course, in your workspace. So the outline is direct, and of course you can just change some of them or overwrite some of them, but it is being placed automatically there for you. Now, when you place wing walls too, right? There were different options to align the wing walls. I mean, apply certain offsets, not only longitudinal along the cab, but then transversally. So uh, again, we couldn't do it. Now we can, right? So just through modifications in the properties, just be a dialog box, you can place the wing wall and adjust it as you need it, and also align it as you need it. So uh, uh, maybe this is not exactly what you do at your DOT. Maybe you require a parametric cell, a functional component, or even a generative component. But at least to start, you got a more closer representation if it doesn't quite match your standards. But if it matches, well, more power to you now, as you can just all adjust how you place your wing walls um, into your abutments. Right? So all different options, and it clips the element automatically too, so there is no overlapping elements here. So, and as I said, it's all done. Uh, it's all done via a dialog box. It's just a matter of adding the wing wall using the our place wing wall tool. All these properties you can adjust it as you place it, right? As you can see, the dialog box is quite busy on that information, right? But if you want to see a react, then place it and then modify each dimension as you see fit. So you can see what's being done and if it adjusts to particular needs or not. So now we also have, well, that we have steel tops and we keep enhancing this, right? So now if we report on the steel tops, now all these properties that are available in the reports, right? Now we have it as well on the item types. So then you can create your custom reports for that as well. So that's one of the enhancements that we have done for the steel tops. Right? So now we also have more options on for steel beams, right? So inner splice can be placed, inner splice plates could be placed as well now. So it's just, again, a matter of selecting this on the dialog box. We also added more options on the behavior of the piers, right? So you will see we have the pier now could be crowned at the top, could be crowned at the bottom. It could be crowned at the top and level at the bottom. So there are more options done on just, again, via a dialog box in which you can apply these enhancements. So this is on the previous version, but then, as I said, this is 10.12, but on 2023, we added more options even to manage the behavior of the cap itself, right? So it could be parallel to deck. We call it crowned deck. So if you have a specific cross slope, now you can also specify it. So, and then of course, not only the cap will move, but then all the beam seats will be arranged or modified automatically as well. So it's just a matter of selecting the option and generate that new cap, right? And we call it crowned deck because it follows the slope of the deck, as you can see, right? Before, the option to align with deck was just the cross slope computed from the both edges of the deck. So more options, footing elevations and DTMs, right? So now you know that we have these elevation options. Well, no elevation. We got depth from the ground, right? As we call it on the elevation constraints. But then what about if you really need to achieve an elevation? Because sometimes, even though we compute the depth of the footing, right, compute the center line of the footing, right, sometimes we need to make it deeper because the relief of the terrain. So now we can do it in different ways, right? So now not only you can specify the depth from the ground itself, right? But also you can just specify, as we specify the terrain, you can specify elevations, right? And if you have, for example, three different footings, you can specify different elevations, even from the different footings that make up your pier. So the way to access this is through elevation constraints, and then just specify the option on the footing, what you want from DTM, right? The ground option, like here, 1 meter below the ground, or 3 feet, right? So, or you can say, I need to apply a specific elevation, right? So if I do this on the elevation constraints right here, if I can select it though, right? Yeah. So we can achieve that and just better take the wireframe out. Or illustration will do it too, right? So we can get this and just show you here, right? So I just can go to the footing and specify that I want different elevations or just a depth from the DTM itself, right? So I can just play with that options and achieve a specific elevation if I need to. Now, also, we apply the skew to the solids, but now it's handled through the caps too, so I can apply the skews to the cap itself, right? We were not able to do it before. Now it's just a matter of specifying I want to skew the caps following the skew angle, and it will just cut it too. Right? So now also a request for that was as well the slope between bearing seats, right? So before it was the step cap option, right? So basically, yeah, steps. But now we can specify not a step, but actually a sloped concrete on bearing seat to bearing seat. So that's any option, again, just through the properties, saying true or false, and activate that option. And some organizations are doing this. So it's just a matter of toggle that on, and we just slope or added the extra concrete to a slope between the bearing seats. So right here, for example, again, showing you that it's a simple uh, setup into the properties, right? So for the sake of time, it's just a matter of selecting the option on properties on how we want to model these uh, slope bearing seats. And it's on false. No, I want it to be true. So it will just modify that and just do it. And then the slope will be done for the bearing seats too. So that's it. It's just a matter of selecting that, as I said, to true, and now it will be just adding this extra concrete to a slope, the extra concrete to the bearing seats. Now, also on the previous version, you know that we have included, and of course it's still there, the GC workflow, generative component in short for OpenBridge Modeler. So some organizations in the US and as well international are using these to handle the more complex structures that a parametric cell cannot handle. So they're using mostly for the abutments, sometimes special barriers and anything that could not be modeled, right? So on that, yes, we have included, and the beauty on that is that GC or generative components is not a separate element; it's actually part of OpenBridge. So you don't need to be a programmer to use it. That's the point. The GC node, as we call it, could be created and as a user, the only thing you need to know is that, hey, I need to bring the node, right, or the GC abutment, in my case, to OpenBridge, and then just place it as a bridge element. So just in short, just place it as a peer, for example, and then the GC element will be placed. Now, maybe it's not going to come to the right dimensions that you want. So then the extra knowledge on your side will be to say, oh, I need to activate the controls in the new workflow that we have called computational design, right? And this is the programming that somebody, or the scripting that somebody else has done. But when you access this, you access the control, and that's what you need to learn: how to change the numbers into the variables, and then the abutment will react to your dimensions immediately, right? And then also it's part of the bridge. So if for some reason, for example, I modify the location of the support line, make the bridge longer or shorter, this abutment will move accordingly because it becomes a bridge element. It's a solid element that, well, you can compute quantities, and you can detail it if you want as well. But this is, on the works. At least we got the graphics and the bridge element there. Of course, there is always room for improvement, and we will continue to do so. So I think there is some questions on the QA box. So Steve, you can answer some of them, and people were asking that. We're going to leave some room for questions. But as I said, this is what we have in uh, the previous version, right, of OpenBridge. I got more information regarding the 10.11 version too. But again, all this extra information is already as well in our YouTube channel or release notes to check how these breakbacks are done and all of that. So please, I invite you to go into that and review. Every video is there with explanation, so it's voiced over as well. So please, I invite you to do that. Because now it's time to switch on what's new, and then that's going to be a little shorter, on what's new on the release of OpenTunnel Designer. So I keep sharing my screen. So this is the power presentation that it comes. So what is new in OpenTunnel Designer? OpenTunnel is a new product. As you can see, we have this. This will be our second release of the software, right? So again, we call it 2023. On So one of the big enhancements there is what we call the lofted tunnel sections, right? So this lofted section basically is not just a regular extrusion, but it's just uh, uh, I don't know how to explain it. It's lofted, right? So it just goes across the beam, following trans- going from section to section, right? So, and that's what the problem is, because it have to be as a lofted solid, right? Like not a regular extrusion, but a transition between section to section, and the solid needs to follow that. So, well, that was the challenge. But now, our programmers have devised the solution, and then yes, we can create lofted solids, and that not only improves the capabilities of the modeling itself, but also remember that the open tunnel, has a transfer to plaxis for full geotechnical analysis. So all that properties go to them, right? So, and it's also done for all the tunnel parts. So the lining, the reinforcements, auxiliaries, every element will get this transition from section to section into the tunnel itself, right? So, and it's just a matter of specifying what are the part numbers, as we call it, the different parts inside the tunnel, and if they're going to be lofted or not, right? And then when you place the tunnel itself, right? So the modeling, it's have you seen the demos of OpenTunnel? It's based on libraries, right? So you can select the different tunnel sections. We use the same concept as support lines, as you can see on the purple lines there. So, well, they are not calling support lines; they're called reference lines, right? But then, and then you place basically a section to section to the tunnel itself. So, and then it works through catalogs. So every section of the tunnel, will you have to create or well, it comes with a library of different tunnel sections, and not only just the outline, but of course the lining part of the tunnel itself. Uh, so different sections, lining, where you place the different reinforcements that could go into a tunnel section too. So on this library, again, you can also create it or modify the ones that we give you, or the more standard tunnel sections there. And then as you specify that, you just basically say, I want my the section of the tunnel that I just placed from reference line to reference line. So we'll follow the red line is the actual alignment and profile of the tunnel, the same open roads alignment that you can use. And then this is the lofting option, right? That's how we are placing that on the tunnel itself. And then maybe go to a different sections or a transition, right? So now we got a circular one, and then when it transitions, right, this is all the reinforcements too that you can place there. So this is one of the major enhancements on this 2023 version, right? Now also the placement on reinforcement, right? So now we place reinforcement in different groups, in different tunnel sections when they are required. Before it was all across the tunnel. Now you can specify in what sections and what type of reinforcement is going to do, right? So one more time, all these reinforcements will be transferred to plaxis in order to do the geotechnical analysis there. So where you place or where you specify where is the location of the reinforcement, it's on the library. So on the catalog itself, that you can, of course, I said before, you can modify it, you can create your own. You specify the location of how this tunnel reinforcement is going to go. And then as you need it, then this reinforcement will be placed across the tunnel section. So and then you can specify that options and the different materials that it could be, right? Could be rock bolts, could be some fiber stuff you could put there. So all of that could be placed as well, right? On each section, on each unit as is being generated along the tunnel. So you can define all these groups and it will be placed. See? So here I don't have reinforcement at the top. And as I specify all these dimensions, sections, you can specify in what section this reinforcement will just go. So adding more sections, also a different type of reinforcement tool. So can specify that again, all through a dialog box, we can specify that type of reinforcement, as you can see, and activate the sections of the tunnel that I generate. And now we have more options. Right. So now also we have included some built-up reports there, right? So again, for users that are not familiar with MicroStation, you know that we can do different kind of reports or using item types, and then you can of course create your own. Well, we have added in this new version already custom reports that are part of the library. You can modify it, of course, but then give you a little heads up on what these reports may look like and how users can as well create it, right? So I know if you're familiar with MicroStation on how to create reports, well, I mean, that is no extra science there, but then sometimes, we're not familiar with the environment itself. So now we show you how these reports could be generated, the properties that are inside that, and how to activate it and place it into the screen. So I would say this is more for the non-MicroStation users, that they're getting a feeling on how OpenTunnel works. Right? And all these properties, as I said, are based on the item types. Right? Also, the ground that we use in OpenTunnel It's coming from IFC, coming from software like Leapfrog, for example. So we have included more options uh, to on new formats, right? That's they are upgrading the export on how to import that information itself, right? So we have that, and so then these IFC versions that they are coming, we are improved. Now also the portals, right? What we call the entrance of the tunnels also could be lofted, could be let's call it sloped, right, along the distance. So we have done that too. Before it was just only one section. So now, as you specify through the catalog, right, through the catalog, you specify the portal to use, right? The section of the portal, the section of the entrance and exit, right? The term is portal. We can loft it all along the distance, right? So as you place that portal through a dialog box, right? From reference line to reference line, you can select the option to specify that enhancement there. So this is the tunnel section. Now I'm going to place a portal section, right? So that will be part of the new on the catalog. And we can just, as I said, place it and just enhance that option there, right? So it's being lofted and also placed on curve as well. Right? So now showing you more or less what we're talking about as we're talking a lot about the plaxis transfer, right? After you model the tunnel, right? In if we don't use OpenBridge, OpenTunnel, so you got to create actually a script that remodels your tunnel in Plaxis to do the geotechnical analysis, right? So, and sometimes these scripts could be quite complicated and could take some time. And if you modify your tunnel section in the model, well, you need to model the or re-script or update the script in Plaxis to account for that changes. Now, the progress here in the software is that all these sections, right, when we do the Plaxis transfer, it's immediate, right? So there is no need to do the scripting. The transferring of the tunnel section to Plaxis, it will write the script automatically for you. By doing that, again, you guarantee that all the information that was modeled will be transferred to to Plaxis, and then you can proceed with your geotechnical analysis. Right now, even more, if there is a modification happening, well, you just send the script again, uh, or update the script, and then the software will write it for you, and then you're ready again to update your geotechnical analysis. So I think we just are on time. So, and these are the enhancements of that two previous releases. As I said, there is an open tunnel YouTube channel too, in which we have a detailed description and videos on these enhancements for OpenTunnel as well as OpenBridge. So if you're familiar with OpenBridge, the uh, placement of the tunnel sections, the concept of the portals and reference lines is almost the same. So you will have no time in learning the mechanics of the software. But of course, I mean, there is some tunnel terminology that we need to be familiar with. But manipulating the software, I would say, uh, if you're familiar with Bentley products in general, like Open Roads, Open Bridge, you can learn it very, very quick. So other than that, that's all I have for you.